All right, everyone. Good evening and welcome to class three. Today, we're going to be going over a bunch of things. My ideal plan has been to make sure that you guys know the fundamentals, know how to use SQL operators and functions, and then start to begin to learn the fundamentals of doing some basic data cleaning and categorization. Now, tonight, after we've learned about how to structure a query, how to translate a business question into a query, and how to identify what data source we might be able to use for a data query, we're actually going to learn how to create those tables and potentially a database. The database will likely be optional, but that's actually not the hard part. The harder part is creating the table. So we'll be doing some of that. We'll also be doing a little bit of cleaning and preparing data. Probably not much, but we will go over some ways that you might want to manipulate columns, rows, tables. Um, and the last thing, we'll also learn about data joining towards the end of class. So a lot to cover tonight, and we'll be doing a lot of interactive exercises. So if you guys all have access to the Slack channel, we have a bunch of files that are posted in the SQL Spring 2023 channel for CSVs, as well as a copy of tonight's slide deck, so that if you need to go back or you need to reference something else, it is there and available for you. So I would highly encourage you download those so that when we get to a point where you need to reference back to something that we talked about earlier in the class, you'll be able to. But anyway, let's go ahead and get started. So just some quick announcements for the beginning of class. Anyone that needs a makeup assignment for the last homework, let me know so that I can send it to you. I still have yet to make it, so I have a little bit of flexibility on the material that we put into this. But if there's only one or two of you that need to have a makeup assignment, then I'll try to tailor it to where you're at in the class. If I feel like there may be something that's misunderstood, I'll try to tailor the homework around those points specifically. And then as a reminder, the course is still pass-fail. So each homework assignment is also pass-fail. You won't be graded on the percentages as an average. You'll just be graded on the number of passes versus the number of fails that you have for the class. Attendance does count for the grade. So just being here is also a big part of your grade. And then lastly, an update on the course schedule. I know last time towards the end of the class, I talked about how I had a scheduling conflict for our class next Monday. I put the poll out and took some answers and thought about how my schedule might be able to align with you guys, as well as how the schedule aligns with other courses. So here is a basic overview of where we're at right now. We're in the Business Intelligence Certificate, and we're taking the Data Manipulation and Management course. And so we had the Monday, March 13th course canceled. And then we've had class on Wednesday, the 15th, Monday, the 20th. And today we are on Wednesday, March 22nd. Next week's Monday class is going to be moved. So we won't meet again until next Wednesday. So we'll have 7 days. And we will have a homework assignment. We'll talk more on that towards the end of class. You won't have to start it tonight, but I will send out the assignment tomorrow once it's finalized and ready to go. And then after we meet on Wednesday, we'll be off, and then we'll come back on Monday, April 3rd for class number 7. And Wednesday, April 5th is where I've moved the last class. So we've essentially shifted the materials, just one more class period. And then we'll be done right before Good Friday, Easter weekend. So everyone will be able to rest easy and enjoy the weekend with family and friends. Any questions on anything we just covered there for announcements?
Nope. Thank you.
All right. Well, let's talk about some of the objectives for tonight. Tonight, it is my goal to help you learn how to find a data set online, download it, and then add it to your database. We'll also learn about table constraints. We'll also learn about altering database tables, columns, rows. But the big things that I'm going to want you to be able to know are how to add a column to an existing table, or rename a table that we've already created, or even drop rows or columns, depending on conditions or depending on the need for the data overall. And then lastly, towards the end of class, we'll start to learn about database joins. After we've learned all about the syntax, how to write a query on tables that already exist, now we're actually going to create our own table. And we're going to learn more in depth about how these tables, the rows, the columns, and the values that make it up can then be used to start to create what's called a data model, which will be the next class that we cover. We'll start to talk more about things like data modeling, business intelligence, analytical cubes versus transactional database. So there's a ton of different things that this will build off of. So if there are any questions that you have throughout the class tonight, please do not hesitate to unmute yourself, ask your question. If one of you has a question, I'm sure that there's others that are probably having the exact same line of questioning as well. So please be vocal. Pause me if something doesn't make sense. And most importantly, have fun. This is a learning experience. So if you're not learning, maybe we'll just need to pivot how we're teaching. But enough said. Let's talk about finding data sets. All you have to do is go to Google or any other search engine and search for free data sets. You'll get millions of results. There's tons of data out there. We're living in an age where there's so much data available that we don't have enough resources to analyze it all, or to hand pick certain rows and certain values that we think might be important to analysis or important to our organizations, or even important to what we want to know as individuals. But there are a lot of really good resources and a lot of websites that aggregate hundreds of thousands of different data sets and make sure that they're available for you to use, or most importantly, for you to practice on. And some of these good places that I found that you can grab data sets from are even ones that you yourselves were researching just a few weeks ago, like Kaggle, Data.World, Tableau Learn. Reddit datasets is a really good location to find unique and interesting data sets that you might not find on other publicly facing websites. 538 also has a bunch of different data sets available. And one of the others that I found that I thought was pretty intriguing was Maven Analytics. Had some really interesting data sets that you can use and download to analyze. But after we go through tonight, I think you'll start to understand how data eventually makes it into the database, but not only that, how to actually create your own table in a database. So for tonight, we're going to be working with a couple of different data sets. I've actually prepared some of these basic data sets for you. Namely, we have Netflix titles, which is just a sampling of the thousands of movies and TV shows on Netflix. It's not all of them, but it's a pretty big chunk. We also have toy sales, which is a mock sales transaction data set for a toy company. So you'll have things like list price, MSRP, cost to the business, who purchased the item, what the status of the order is, things like that. And then I also have a biking data set. I've actually been tracking all of my bike rides for about a year and a half now. And I have a few different attributes that I think were fascinating to actually track myself when I was doing some of this analysis. So we'll actually be using that for a lot of the examples tonight. No bias, clearly, but I think it'll allow you guys to think about something a little bit more simple and hopefully connect the dots from logging the information, talking about where the data comes from, how the data gets into its format, and then ultimately putting it into a database for you or anyone with access to the database to analyze and to further understand and even advance your own scientific goals. One of the reasons I started tracking this data to begin with was because I was always keeping kind of a mental scorecard when training on the bike. I was always focused on either increasing the length I was able to go in a single ride or improving the average miles per hour that I traveled on the bike while I was doing my workout or whatever. And then there was also a factor of being able to go a certain amount of time for a certain amount of miles per hour, trying to have like an endurance mentality. Um, but you can use that data to track your progress, see if you're trending upwards, see if you're trending downward, and then you can use that data to make decisions in your own personal life. So for me, when my average miles per hour started to go down, I started to think about what I was using to fuel myself, whether it was good food or it was not drinking things like alcohol or um, just things in general that would affect your ability to perform athletically, or things that you can look out for. And then you can realize those results in terms of numbers. You can see that the bike rides either went longer, or I was able to travel faster, or I was able to travel faster for longer. So there's a multitude of ways that you yourself could collect data. So this is hopefully an example of teaching you how you could collect data and then put it into a database and then join it with other tables, or even put it into a Tableau report without having to import a Excel spreadsheet or a CSV, or carry it around everywhere you want to view the Tableau dashboard. So all that said, let's actually start to get into some of the learning materials for tonight. First off, how do we add a table? This is one of the most basic commands that you'll do, and it's also a common starting point when building out a data warehouse or just a robust database, whether it's for yourself for your company. And there's a multitude of ways that we can create a table. One way is to actually create the table using inline SQL and understanding how that SQL syntax works. And so here, this is an example of how we would actually create the table that we would insert data into in our database. So that first line of code, create table biking sessions, is actually going to bring our table to life. This is what declares and allows us to declare how the table will be organized. What do the rows represent? How many columns do we have? What data types do each of these columns use? And so all of those questions can be answered right here in our schema declaration. We have our column name. We have any constraints that we want to add to that column. And constraints you can think of are like data rules. So one of the constraints that we have on here is on ride number, which is our primary key towards the bottom. That's also a constraint. Is that it has to be not null. So that not null clause at the end of the line for ride number indicates that anytime we want to insert rows of data into this table, call it biking sessions, that ride number value cannot be null. Now, if a row of data or a record of data were to be attempted to be inserted into the database and that value was null, that insert statement would actually automatically fail because of the constraints that we've set up. So it's going to force whatever is importing data into the database, whether it's inline SQL, which we'll talk a little bit more about tonight, or if it's an API that's writing directly to the database from an application with the values that we're wanting to analyze. Every time that value is attempted to be inserted as a null, that command will fail. So it prevents us from having potentially bad data or introducing a bug into the application itself that is creating this data and loading this data into the database. Another example of a constraint is the auto increment. So right there, that auto increment, what it's going to do is every time a new row is entered, you technically don't have to declare what the ride number is. So the not null clause may not be necessary with an auto increment constraint, because every time a new row is inserted, it's going to look at the last value that is stored in that column for the entire table and then insert that last value plus one. So if we have, I think this table has about 130 rows. If we insert another row using an insert statement, which we'll also talk about later, we would just have to declare what date the ride occurred on, the amount of miles we traveled, the time in minutes that this ride took, and the average miles per hour that we traveled over this entire time. Um, and then when we insert that ride number would automatically be populated with 131. So other than that, the basic syntax, the way you can think of these create table statements is we're always going to want to declare that we are creating a table. And then we name our table. And immediately after the table name, we create a paren or a set of parentheses so that we can add every single column of data and declare what rules we want to apply to the table. So, like I said, in this case, ride number is our primary key as indicated at the bottom of the query. And then we have 5 different columns that are going to be on this table. We have ride number, which is our auto incrementing primary key. That's what describes what the table is storing. So in this case, we're storing bike rides. And then any of the other columns are describing that bike ride. Because the auto or the primary key is what makes this table unique, shows its granularity. And then we have a date column. What day did we take this ride? When we add this date dimensionality and we have another table like calendar that also stores dates, that calendar table could also store things like what quarter the day was a part of, or what week of the year the date occurred on, or even what day of the week did the ride occur on. We could start to pull more advanced analytics once we learn how to do data joins with this date column. Once we join that date column to the date table, we now have access to group our entire data set for biking sessions by any of the columns that are in our joined table. So for calendar, anything that we put on there, we would be able to do aggregates by those groups without having to do any additional coding. Once it exists on the one table, it can exist on any other table that matches that join criteria. And then we have distance miles, time minutes, average miles per hour, ride number. None of these are going to have what's called a foreign key constraint. And on this particular example, we don't have a foreign key constraint. But what this foreign key constraint does is it allows you to programmatically introduce what's called an index into the database. We won't go too in depth on what indexing does or what it's meant for, but think of an index like a library catalog. That's an example of an index. It tells you what books or what resources can be found where. The same goes for a database index. A database index is simply doing the same thing. It's saying, what data do I have? Where is it? And how is it stored? How is it ordered? And so those foreign key indexes will allow you to reference another table that this particular column can be referenced by. So in this case, if we wanted to add a foreign key constraint, after that primary key line, we would add another line that says foreign key, and then the table and the columns that are applicable to that particular foreign key. But that's a very basic overview of how you can add a table to the database. The most important part of adding this table is, though, declaring the schema. If we don't declare the schema, if we don't define what each column represents or what each row represents, then our data is just a static table. It could be values, it could be varchars all the way across, but we don't take advantage of any of the other specificities that we get out of these different table declarations. But this is a very basic way of adding a table to the database. What if you want to add a column later? Let's say you have all of these different columns that are already stored on your table. You're going to import it, but you don't know what data you might want to have later. That's totally fine. This is why we have an alter statement. So just like create, alter is another statement similar that will allow you to alter the table schema. When we think about CRUD operations, create, read, update, delete, create table is a part of create, and alter you can think of like an update. We can update an already existing column. We can update an already existing table. We could even update an existing row, even though that's different syntax than the alter table. But what this alter table statement allows us to do is to add columns, manipulate columns, change a table name, change the data type that a particular column is stored under. And it allows us to have some sort of flexibility in maintaining our data set long term. Most of the times, we want to have our schema stay the same. However, there are practical reasons for wanting to change it. So this statement will allow you to do so. And in this particular example, we have an alter statement for the biking sessions table. So similar to how we just created the biking sessions table, now we could alter it. Let's say we wanted to add a column and we wanted to add a custom column that's computed off of a set of rules that, like, let's say we wanted to classify the ride difficulty. So, like, how hard was this bike ride by the amount of miles that was actually a part of the bike ride. So all we have to do there is program our rules so that our values can be lumped together. So when we alter the table, we're going to declare what it is we want to do. Do we want to add a column? And in this case, that's what we're going to do. In the second line, we talk about, or we have written add column, call it difficulty rating, and give it a data type of is basically a string, a varchar, and allow that string to be 25 characters in length. We can have this go all the way up to 255. We could have it go up to 1,000. We have it set to 25 because we have no need for more than 25 characters in this column. Just realized we got a ticker going across the screen that says class started 20 minutes ago. So please ignore. So back to what I was saying. When we create these rules, after we add the column, we want to add a line of code that says we want to generate this column always as, and then in parentheses is where you're going to put your rules that you want to program for your table. So in this case, the rules that we outlined were that if a ride is less than or equal to 10 miles, we call that an easy ride. If the ride length was between 10 and 20 miles, call it a moderate ride. And then if the ride was between 20 and 40 miles, that was a pretty hard ride. And then anything more than 40 miles in a single session is very hard. And I can justify that. 40-mile plus rides are very hard. Just kind of a fun fact. When you compare like a bike ride in terms of length to like a marathon runner or a half marathon runner, the equivalent to bike a mile that someone runs is about 4 miles. So the difficulty for someone to run about 1 mile is about the same difficulty for the same person to bike about 4 miles. So biking for 40 miles is about the equivalent of running for 10 miles. And I think a half marathon is 11 and a half miles. So the milestones for biking are things like 25 miles, 50 miles, 100 miles, because you get a quarter marathon, a half marathon, and full marathon in those lengths. So eventually, if I was able to bike maybe more than the 50 miles, I might want to come back and alter this table so that I can reclassify the difficulty rating column to something that is maybe a little bit more suited to my abilities now. I might change the easy rides up a little bit. I might adjust that rule to be less than or equal to 15, and then adjust the moderate to a different rule, say 15 to 25, hard rides for 25 to 50, and then anything more than 50 miles, make that very hard. The point is that no matter what you declare your schema as today, or when you create the table, you always have the ability to come back and alter it. There are some considerations that you have to make, though, when you alter a table, which I will talk about in a later slide. But now that we've learned about how to create a table and then alter a table or alter a column, does anyone have any questions so far on these first two?
I had a question on the last slide.
Okay,
Where
let
does
me
primary key, could you add like where's this ride underscore number? Can you add another primary key and just put in like comma? Or do you have to do primary key and then again like that same
Uh,
declare?
you hit it right on the head. So you can have multiple primary keys, and when you have that secondary primary key, all you have to do is add a comma after your first variable. So in this case, you'd put a comma after ride number, and then you can add the next column after that comma. So let's say you take multiple rides in a day. You may have a ride number that's unique, but you want to classify everything by date. Um, if you were to have the same ride number, then you might want to add date so that you can have a granularity of taking a bike ride on or multiple bike rides on the same day. But back to your question, yes, if you wanted to add another primary key, you don't have to add another line that says primary key with the column 2. All you would have to do is add a column after the variable or the attribute column that you've already declared right after it. So hopefully that answers your question, Brenda.
Yeah.
And then just to piggyback off of that, can you just kind of briefly explain the primary and foreign key again? I've seen them and I know that that's kind of like what you join on, but I'm just a little rusty on like the actual definition.
Okay. I'm trying to think of a good way to re-explain this. Think of the primary key as a number or a value that is distinct to a particular table. And maybe this helps to actually have an example up. So let me pull up the database or the data set that we'll be working with tonight. But you can see right here, I'll zoom in, that we have our data here. So we have ride numbers, we have dates, we have distances, times, and average miles per hour. These are all columns that describe what this ride was. Because we can always refer back to this and say, well, on ride 1, this is the date that it happened on. This is the amount of miles that were traveled on ride number 1. This is how long ride number 1 took. But that number doesn't really indicate much other than identifying and assigning some particular value to this table. This ride number is what indicates the most granular level of our table. So what describes the most basic element that we're trying to measure. And in this case, this table is measuring bike rides. So we're going to want to have an ID that uniquely identifies these particular rides. We don't want to have duplicates because if we were to have another line here that said, well, here's ride number 1 and here's ride number 1 as well. They could happen on different days. They could have different mileage. They could have different minutes. So that would be the definition of not being unique. And so these primary keys identify that like I said, the most granular row in a table. And then foreign keys are a little bit different. An example on here that we might have for a foreign key is this date column. And so when we declare a foreign key, you can kind of think of it like a data join. The foreign key is going to say that this column or whatever column you select, and in this case, we'll use the date column, corresponds to a value, like a similar value or a similar column on a different table. And that indicates that you can successfully join the two tables together. And so when you join on the date column, you're saying that this date occurred on call it the calendar date. And when you join these two tables, since that foreign key constraint is there, it allows you to automatically index or programmatically index so you know where to find particular values. And any of those records that you have can then be aggregated based on the values on the other table. So if we look at like the calendar table, for example, we have this date column, right? And these are values on two different tables. So if we put a foreign key constraint on the on this column right here for the biking table, that means that any value that comes into this column has to match a value on the other column. So that means that if we have a foreign key constraint on the date value or on the date column for our bike rides that corresponds to the date column on learn.calendar, that means that dates for those bike rides can only occur on dates that are in this table that we set the constraint up for. I know that that was a little bit difficult to explain, but hopefully that gives you an idea of maybe the differences between the two. That's a pretty tricky question. So sorry, did that make sense?
Yes, a little bit. I think just with more like practice with it, it'll make sense. And then just one other question. I noticed that you put generated always as. Is that a required declaration? That was kind of like my first time, seeing that when making a table.
Sorry, say that again.
You put generated always as before your case statement.
Yeah.
Is that something that's like required when you are adding a column? That's like my first time seeing that. So I was just wondering.
So for all the tables that I've created, I've used generated always as.
Okay.
Let me see if that's required. I'm pretty sure it is.
Okay.
Is generated always as required?
Is that more so like the MySQL program that you may use? Is that because we've used another like Microsoft or and so we've never used that. So I think that was the question brought up.
Yeah, it looks like it's optional. I haven't used MySQL for several years now, so I'm also kind of learning along with you guys. It looks like it's not a requirement. So all you could do is instead of having generated always, you can just do add column, the column name, and then the data type declaration, and then just do as with the parens afterwards, and then any other clauses that you want to declare. So not required. And I'm learning something new every day. So
I mean, same. I love to learn as well. So I was just wondering when I saw that, I'm like, oh, well, that's cool. I wonder if that would I don't know, help with the structure or help with things being, I don't know. I was just wondering. That's all.
That's all good. Any other questions? These are all good, by the way.
Not so much a question, but I do like how you're laying this out with the definition to the right, the alter table. As someone who's new to all this, seeing why that's done, I really like that visual because that helps me understand why you're putting that in there in a very static way.
Yeah, and I'm going to touch on that a little bit. So those things to the right of the code, each of those lines, right? Those are comments. And in MySQL, there's a couple of ways that you can add comments to either your query tabs or maybe one day you'll use a different program. Like if you've ever heard of a data notebook before, like Jupyter notebooks or Databricks notebooks, you'll have multiple ways that you can comment things out. But one of the parts about SQL, and especially learning SQL when you're either on the job or you're working at another organization, is being able to understand this code, right? And so I've tried to start, a lot of our courses with some of the like fundamentals of syntax, so that you can understand like the different things that you can do with data, because there's so many different jobs and there's so many different functions out there. But you don't necessarily have to know how to do it all. However, when you do inline comments, it's at least going to allow the reader or the recipient of this code later on down the road to be able to understand your thought process when you're trying to structure like a piece of code, or be able to explain maybe the semantics if you have a little bit of a difference between maybe a similar block of code. And so when you add these comments, it's best to add something that provides value. So if someone's coming in and has never seen your code before, they might be able to deconstruct it or even reverse engineer what it was trying to do. And so hopefully, if you ever find yourself having a hard time maybe phrasing out how you might code or create something in like an inline SQL, my recommendation is to maybe use some of these notes or remember the structure that this code is made in with the comments, and be able to like wireframe your question. So if I want to add a column on a table, I maybe don't have to remember that alter table is my statement, but just know that when I Google, how do I do this? It's how do I create, or how do I change a table schema? How do I add a column to a table that already exists? And then most importantly, how do I add a column that's maybe derived off of a formula that we've created, or even rules? So sorry about that. Glad to hear that the comments are working. But just a little side tangent there on the importance of making sure that your code is commented, or at least able to be understood by someone down the road. If there's one thing I've learned in my career of data analysis, engineering, and science, it's that you'll probably create code, and then down the line, you may leave the organization or you may go somewhere else. But someone potentially is going to pick up that code, and they're going to either have to dissect it, or they're going to have to re-engineer it. And so the easier that you can make it, the less churn that they'll have when that time comes. So anyway, like I said, that's a little side tangent on making sure that code is commented and easily read. Any other questions on these two slides before we continue? All right. So another thing that you could potentially do here, what if you don't like your table's name? Or what if you don't like your column's name? That's totally fine. We have another update statement for this. And if you want to rename a table, all you have to do is write rename table, whatever your old table name is, and then to whatever you want to rename the table to. But as easy as this might look, there are tons of ramifications to renaming tables, renaming columns, even doing a lot of these alter statements that we just discussed. Changing a table or a column name could actually break components of an application that are built on top of either that table or that column. These are called dependencies. So anything that this code references or other code potentially references this table will have to get updated to actually work properly again. So there is a little bit of overhead when you decide that the table name maybe isn't representative of what you thought it was, or that a column name wasn't named the way that maybe like a company restructure is mandating a column be renamed to. But you do have the ability to make these updates. But when the updates are made, it is important to know what services and processes are built off of either the column or the table that this newly renamed column now has to be repointed to. So communication is always a big piece of table maintenance. And it can be especially hard, or it can be especially hard the larger the services are, or the more, call it like spider webs or tentacles are out from the application. But some database objects, other than applications, could also break as well as a result of these alters. So there's things called views, there's stored procedures, and foreign key constraints. So when you make that foreign key constraint, if you change the name, that foreign key constraint is now going to be broken and would need to be reprogrammed. You may even encounter an error when you try to alter the column that says that you can't because there's a foreign key constraint on it. So just be aware of what the consequences may be if you alter a table, rename a table, drop a column, add a column, change a column's name. But once they're updated, everything should run perfectly normal. So that is a little warning on making alterations to a table, renaming tables, anything of that nature. So we're at the part where we're actually going to start talking about importing a table. So we're going to go through this slide, and then we'll probably take a short break. And then we're actually going to come back and start to do this ourselves. So we're going to create a table. We're going to alter a column. We're going to potentially drop a column. We could add foreign key, primary key constraints. But how do we do that? How do we actually get data into a database? Because up to this point, I believe your experiences, at least in data manipulation and management, we're either doing a local database where we do kind of that third option, which is where we use our own code that imports a local file using a function called load local in file. We won't be doing that today, and that actually doesn't work for our environment. This is just a AWS database hosted issue, so nothing more than compatibility. But there are certain cases where you may want to do that load local in file. Kind of like if, I think for maybe doing software installs, if your application uses a localized database, you may be able to write your table to point directly at a CSV that it has to load, or even just creating tables automatically in the local database. That might be something that you could do. But there's actually two other options that I wanted to propose here that I personally prefer when importing data manually. The first way is that you can import a CSV using the MySQL file import tool. And there's a couple of ways of doing this. But the way that we're going to outline tonight requires you to do that create table statement where you define your schema first. You basically create a blank table with the outline that you want to store data in. And then you'll actually go through that import wizard and say, okay, I want you to use the table that I just created. Here's the columns. You'll unselect any columns that maybe brought in an error or that you just don't want to bring in. And then there's also another way that is kind of a workaround, but I've actually used this before. You could actually create a custom SQL file using any of the CSV to SQL converters that are out there on the web. All it asks you to do is give it the CSV file. What is it that you want to import into SQL? And then you can do a few other things like define the columns you want to bring in, change the data types, change the column names, and then it automatically spits it all out for you in a nice clean SQL format. So all you have to do is run it. And like I said, this option I kind of prefer. It allows you to import a lot of data much faster than that data import tool because you can actually import tens of thousands or hundreds of thousands of rows in one command instead of the MySQL file import tool going one line at a time. So it takes significantly longer, but it does require an additional step in the process, which is why I mentioned it in the first place. So now that we know a few different ways that we can actually get data into a database, we'll get into some of the examples here after our break. So we'll take a quick 10-minute break and then we'll come back. So before you get back, make sure that you have your MySQL workbench open and connected to the Learn database and your own user-specific database. And make sure you have all those files downloaded that you need. So if you're on a PC, download the non-Mac suffixed files. If you are on a Mac, download the files that have _Mac in the name, and we'll actually use those for the several examples. So we'll take a quick break, and when we come back, we will be doing some demos. So hope you are all ready and excited. All right, hope everyone is back and ready to do some table imports. It should be fun. So just want to make sure everyone has MySQL Workbench open. They were able to connect, no issues there.
Yeah.
All right. Sounds like everyone was able to get it open successfully. So let's go ahead and get started. So we just talked about how to actually import a data set or the multiple ways of importing a data set. Now let's go through each of the specific examples of how we can actually import these data sets. The first one is going to be using the data import tool that's built into MySQL Server. And the method that you'll want to use here is first you'll want to go through the create table clause. So name your table, define the columns, what data types are each of the columns, can they be null, should they not be null, do we want an auto increment on the primary key, do we have a primary key, and then if there's foreign keys, we'd want to declare that here too. After we create that table schema on the database successfully, the next step is going to be to create or to write a select statement from that table that you just created. And you'll notice that as you can see right here in the slide deck, there's no data in the table whatsoever. The only row is showing null for every column. So after you run that query, there's going to be a button right here that's circled, which I think I can zoom in for you. Right next to this table with the floppy disk save icon. And this is what you're actually going to use to start the import wizard. And then you'll walk through the import wizard. You'll find the CSV you want to use, click use existing table, drop any unexpected columns, which I've circled here in red as an example. And then you begin the file import and allow MySQL Server or MySQL Workbench to process through every row in here. So we're actually going to do a live example, and everyone will be able to have this same experience in their own database. So the first thing I'm going to do is, since I already have a table in my database, I'm going to drop it. So let me drop this quick. Oh, and I need to declare a database. All right, so now my table should look relatively similar to your guys's. So now that we have the table dropped, let's actually add a table. So first thing we're going to want to do is reference the PowerPoint and some of the syntax that we have here. So in this case, we actually have it right here in this screenshot. It's going to be very similar to what we want to bring in for this table. So the first thing we want to do is declare what database we want to use. And in this case, we want to use the learn_our_name database. And then you'll run that. And another note that I'll make here is if you don't want to include this line, you can actually include the database reference in each of the lines of code that you have. So when we do the create table statement, all you would have to do is add learn_yourname.biking sessions for this particular table, which we're actually going to use here. So I'm going to remove this just to show as an example. And we're going to start the create table statement. So the first thing you'll want to do is write your create table, because this is what's going to allow you to add columns, declare the schema, so on and so forth. And then we want to notate where we want to create this table, because as we know, databases contain tables and tables contain columns, and each of these columns describes a row or a record. So in this case, since we know what columns we have, and if you don't, one of the ways that you can do it is actually come into the data source that you're working with, look through the data that you're going to work with so that you have an idea of what you can anticipate to be imported into the database table, and declare what each of these represents. So we're going to have a column for ride number. We're going to have a column for date. We're going to have a column for distance, a column for time, and a column for average miles per hour. So since we know that, we could always throw it on a different screen, or we could just close it down and then start to write our create table statement. So I'm actually going to call this just biking. You can call it whatever you'd like. And then after that, we're going to open up the parentheses so that we can define the table that we're going to create. So now we want to add all of our columns. The first one is going to be ride number because that is the first column we want to import from the schema. And another note that I want to make is that you don't necessarily have to write the columns in order, but it will help you and make it much more simple to walk through the script later on down the road. No pun intended. But for ride number, since I know that we're storing numbers in here, I'm going to declare it as an integer. You could technically declare this as a variable character of varchar, or you can declare it as a string. You can declare it as a big int. You can declare it as a float. You can declare it as a double. There's multiple ways that you can define what data this column represents. But for simplicity's sake, integers are usually the best way to identify a row. There is also a thing called a GUID or a GUID, a GUID, a generic user ID that you could also use. I can't remember off the top of my head what that data type is, but a lot of applications for organizations use these GUIDs instead of the integers. And this is simply from a security standpoint because it could be easier to remember a number or like what row a particular record lives on, but it's much more difficult to remember a GUID because these GUIDs are made up of letters, they're made up of numbers, and it's a large combination. It's 30 characters long, can't really pronounce anything in the string. It's very difficult to remember. So some enterprise architects for data will actually prefer to use those GUIDs instead of an integer ID, just due to security reasons and to prevent, like, if there's any unknown access into the database and someone's in there trying to figure out how the data is modeled and trying to put these things together, it's going to take them significantly longer to figure that out unless they dump all of the tables. So just a side note on some ways that you could declare a unique identifier or I guess in this case, a primary key in your table at the source. But in this case, we're just going to declare this as an integer. And since we can always guarantee that ride number is going to be filled out, we're going to say that this should be not null. And another constraint that I want to put in here is auto increment. And I think I need to have an underscore. And that auto increment, like we talked about, whenever a new record is inserted, the auto increment is going to figure out what the largest value is for that ID column, and then use the number immediately following the maximum value in that column. After you've declared all of the different things that you want your column to exist as, you can start to add your other columns. But for the biking, or for this example, I'm actually going to add some comments so that we know why we're creating this table. I'm creating this table to show how bike rides have trended over time. And then for the first column, for ride number, I'm going to say that this is a number value representing a ride must be filled out. There must be a value in this column for the record to be inserted, or for any record to be inserted for that matter. The next column that we're going to want to add is the date column, which is also the next column on the spreadsheet. And I'm just going to declare this as a date format. There's only two different ways that we can declare this. We can either call it a date or we can call it a date time. If we wanted to do date times, there could be some benefits if we were to store, say, the date and the time that a ride either started or a ride ended. We could group together times from rides and say if the time portion of our date time value, which is only stored in one column, So instead of having a date column and then a timetable, we could have a date and a time in one. And then based on that start time, we could draw conclusions about how our distance fares based on the time of day that we ride. Or we could even draw conclusions if the data indicated it, like bike rides at night tend to be shorter than bike rides in the morning or during the middle of the day. But this is just an example of how you could potentially change the data you store, and then add even more value to what you're trying to extract out of it. So for this date column, I'm just going to say that we only track date now, but may change to date time. For the next line, scroll over. Next column that we have is distance. And since this is stored as a decimal point in our spreadsheet, there's two ways that you could store this. One, you could store it as a double. Two, you could also store this as a decimal. And I'm going to store this as a decimal just for this example. And I'm going to declare the decimal as 3.2. This means that from the left of the decimal, we can have up to I'm trying to think of the word here. 3 significant digits on the left side and then 2 significant digits on the left side. So this means we could store up to 999 to the left of the decimal point, and we could store up to 0.99 granularity on the right side of the decimal point. So our theoretical max here would be 999.99, and our theoretical min, even though you can't bike in negative distance, is negative 999.99. But I'm going to declare this here. Chose decimal 3.2 because there is no way I'll bike more than 1,000 miles in a trip. And these are some of the considerations that you'll make when filling out like a table schema as well. Like this, for example, is a relatively easy example. How long could I potentially ever ride on a bike for? Or how many minutes could I ever ride for? Will I ever surpass the maximum or minimum value that I'm declaring here in my schema? And if so, should I open those values up to something more? Should I make it less? And we'll talk about some of these considerations towards the end, but just remember that there's something called the 5 V's of data. So when we declare our schema, we're trying to control some of these so that we can reduce the amount of space required for this column while at the same time maintaining as much accuracy as we can. So after distance, our next variable is time minutes, and we're going to store this as an int because we know that it's stored. Let me pull this up because we know we don't have any decimal points, so we're not tracking like seconds or fractions of a minute. But if we ever wanted to, that would be a case where we would want to alter the column and change the data type. We might not have to change the column name, but we would alter the table to update the column and change that data type to, say, a decimal, or we could even add another column to have like number of seconds outside of the minutes. So we could have like on this row here, we could have a 78-mile or a 78-minute ride, and we may add on 30 seconds or 35 seconds just for that specificity. So we've declared this. I'm not storing fractions of a minute. Integer will do instead of decimal. And I think the last column that we have is our average miles per hour. And this is stored as a decimal. I don't think I will ever travel faster than 99.9 0.99 miles per hour. So this should probably last the life of the data set that we're going to create and maintain. So decimal 22 is more than fine. And then the last line, we're going to declare our primary key. So primary key and foreign key constraints are optional when you create a table. Primary key constraints will help you in the long term, especially when someone's dissecting this table, because they'll come across the constraint and realize that that particular column is what defines uniqueness on a row or a record. So we're going to declare it here, primary key, and then in another parenthesis, whatever that column name was. And in this case, our primary key is ride number. So we're going to put ride number in our primary key declaration. And then finally, we're going to round this out with a semicolon. You have to terminate your statements with a semicolon. So now that we have this here, we'll run the entire script, and you should get a success notification in your action output that the table was just created. So would everyone be able to post in the comments whether you were able to get the table to successfully create, or if you ran into any errors? And if you ran into any errors, we'll take a look at each of them.
Did you say just to put it on the chat it went through, or?
Yeah. If you were able to get the table to create successfully, just drop a yes or
Okay.
I got it in the chat so that I know. And then if you run into a problem executing the statement, we can debug that too. All right. James, it looks like you got a table created too. Is that right?
Yes, sir.
Awesome. And then see, Rochelle got it, Ted got it, Brenda got it, Anna got it. Ryan, were you able to get it to work?
No, and I'm so far behind, I don't want to slow up the class. So just proceed as if I did.
Could you actually send me your code through Slack, and I can help you out here?
Okay. But don't let me slow anyone down.
Okay, so I think everyone has the tables created for the most part. Ryan, I just sent you some code that you should be able to use to run. So just try and compare your code that you have now with the code that you have there. And if you have questions, let me know. But now we're actually going to get to the fun part where we import the data. So we're going to use the import wizard that's in MySQL Server. So first step that we need to do is we need to actually query the data that we just put into this database table. So I'm going to select star from my learn database biking table, and I'm going to run it. After I run it, I should have no data in here at all. The only row that's in here is null. And you'll see that we have this import records from an external file button. That's what we're going to want to click. So after you click it, the wizard should pop up and ask you, all right, you can use CSV files or you can use JSON files. And you could also create it on the fly. We're not going to create it because it's already been done for us. So you'll browse, you'll find the data set that you want to use. In this case, I'm going to use biking. And after I select that, I'm going to click on next because we'll have a valid file path. And then once you guys have that done, okay, I'm actually going to switch this here. Sorry about this, everyone. New query tab. So after the wizard pops up, we'll go next. I want to use an existing table, and you should get the table to pull up here. I'm having problems, so I think I need to just close out of this and restart. Try again. Let's see if this works now. Still not working. Okay, so I guess it's not going to let us do this tonight. Fun. Shows that the table's there. When I try to import from an external file,
So I'm good.
were you able to get the use existing table to pop up, Ted?
Yeah, I clicked to load the table. So table data import.
Mm-hmm.
Yeah, and I picked the biking
Okay.
file. I can share if you want to see it. It's up to
Yeah,
you.
go for it.
All right.
And if you can't share, let me know. I might have to change a setting here.
Sorry, just figured it out. So now, so I got it to the file
Yep.
import.
And you'll want to use existing table because we've already created this table.
Right.
The direction I was going to show you is after we create the schema and define it, you want to use that existing table because it's already there. And that's going to point directly at the table that you just created. And then you can click next. And it looks like we don't have any unexpected columns. We have ride number, we have date, we have distance, time, and miles per hour. And it looks like it even looked at the destination column and matched it exactly. So you remember the part I was telling you all about the order of the columns that you write in your create table statement don't necessarily matter as much when you import, because this would be the section of the import wizard where you could define exactly what each of these columns corresponds to. So in this case, it looks like since we did it in the same order, it automatically populated with the destination columns we were expecting. So all we need to do here is verify that the sample data looks good, and we could even cross-reference this with the source table to make sure that it brought in the right data. That step isn't maybe necessary here, but if you want to do it, we can all do it together. but it's generally just a good quality assurance step to take when you're importing data. You want to make sure that it matches your source.
Looks good. So
All right. So if it passes the smell test and we think it's ready to go, next step is just to click next. And it's going to say, here's what we're going to do. We're going to prepare the import, and then we're going to import the data file. If you're ready, click next. And it's going to take a little bit. So like I had mentioned, this is one of the slower options. It's not as fast as the other examples that we'll go through. But this will allow you to have a little bit more of a user-friendly experience when importing a small data set. If you're importing a large data set and you want to use like this import wizard, it won't be as fast, which is why we'll actually want to use the next method that we talk about. So looks like we have a success here. We have 134 records that were imported, and that should match the amount of rows that we had, right? Yep. So since we had column headers, it automatically filtered that out and just imported the data straight away. So now the next thing that we can do is run our select statement again, and boom, we have data. I don't think it's, it is ordered, so it's still ordered in ride number, but it doesn't look like the average miles per hour was imported correctly. I wonder why.
you're a fast guy. About 1 mile an hour.
Yeah. I wonder if it's due to our declaration.
I got the same results.
You got the same results? Okay. So here's what we're going to do. We're going to write an alter table statement, and we're going to update those decimal columns to something that's a little bit larger. The 2.2 and the 3.2 may have been our error. So we're going to actually update those data types to 10.2. So just give me one moment. Okay, so alter table, your database dot table, modify the column name. So in this case, the columns that we want to modify are distance. And then after that, declare the data type that we want to change it to. So in this case, for the alter table statements that we will want to run alter table and then your database dot the table that we're working on. So Ted, for you, it would be right there, exactly that. And then on the next line, you'll want to write modify, no comma. And then the two columns that we want to update are distance and average miles per hour. So modify the distance first and call that, we'll rename that to decimal, and then in parentheses do 10,2 end parenthesis.
And can you just explain why we are doing this again?
My guess is that it's due to just a data type error. I may have explained this data type wrong. Decimal. But when we declare the decimal point, we declare distance as I think 3.2 and average miles per hour as 2.2. So what this is going to do is it's just going to open up our ability to have more precision. And so for that 10 place, it's going to allow us to store a longer set of data or process a longer set of data. In this case, it looks like for the 2.2 comma or the 2.2 column, it only allowed us to go up to 1 in this particular example. And the distance, since we had 3.2, it let us have 2 decimal points of precision, but it's capping us out at 9, it looks like 10 miles here. So we're just going to change the data type of that column that we just declared to something that's a little bit bigger than what we had previously. So 10.2 is going to be much bigger than the 2.2 and the 3.2 that we declared. And it should fit every hypothetical value that we would ever want to store here.
So I'm modifying the average miles per hour decimal to 10.2 as well. Or what did you say?
So we may have to write 2 statements for this. You might be able to run multiple. Yeah, so you can do multiple. So if we want to modify 2 columns at the same time, you'll want to put a comma after each modify statement. So we'll have alter table, your database dot table, modify the column that you want to modify, and then what you want to change about it. In this case, we're going to change the data type to decimal 10.2, and then we'll put a comma at the end of that. And then the next line, you keep you do another modify statement for the other column that you want to manipulate. And in this case, that's average miles per hour. And then we define how we want to manipulate it. So we want to change the data type of this other column to 10.2 as well. And then after that, you'll terminate the statement with a semicolon. And then we'll rerun that. And now, even if we select it, I think it may not change those values. Yeah, so it's going to retain the values that we imported. So now we're going to learn another statement, which is the truncate table. And what this truncate table statement in the background is doing is it's dropping your table and then reloading the schema, but with no data. So we would be able to go through the import wizard process again to diagnose whether this fix is going to resolve the problem that we're seeing here, which is that our distance values and our average miles per hour values don't match what we see at source. So to do that truncate table statement, we're actually going to write truncate and then whatever your table is. So it's TRUNCATE. And then you'll want to write what the table name is that we want to truncate. So in this case, it's learn underscore your database user dot table name. And then terminate the statement with a semicolon. And then run that. And now all the data that we just had in that table that we loaded unsuccessfully should be gone. But the schema is still the same. So what we just altered the table as still exists exactly the same as that alter statement did. So now we have no data in it. The schema should match what we want it to be. And now we just have to rerun through the import wizard one more time. So after you select everything that's in the blank table, you can activate the table import wizard again and go through those same steps that we went through and re-import the data. And we'll check and verify afterwards that it was imported correctly. Ba-da-bum, ba-da-bum, ba-da-bum. All right, there we go. We got good distances and good miles per hour. So that appeared to be our fix, and a great example of case where you may have to alter a column data type and potentially anything else for a column. there are going to be times where the code you write isn't perfect, or the examples that your professor gives aren't the best. But that is a good case to say that we can still fix it. There are ways that SQL will allow us to manipulate columns, change columns, and even change the meaning of columns. And this is just one case of many. Was everyone able to get the table to load successfully using the import wizard? Did anyone run into any errors? I'm sure everyone kind of ran into this similar problem.
I got it to run, but I don't think mine's changed. I'm gonna go through this one more time.
Okay. Rochelle, you want to share your screen? I can help you walk through it.
Mine went through.
Awesome.
So, but the only thing I did put truncate table instead of just truncate, but it still went through. So
Yeah, okay, that's fine. That's also totally fine. You can do truncate table, you can just do truncate and then the table name. Doesn't matter. That's another code point of it's just your personal preference, whatever you prefer. Rochelle, did we want to walk through the example that you were asking about?
Sure, I was trying it one more time to see if I could get it to work.
Okay.
It's loading now, so
All right. Fingers crossed. Drum roll. And while we're waiting, was everyone else able to get the table to load? I know Brenda and Ted, we were good. Anna, Charity, Ryan, James.
I'm getting an error message.
Okay.
No, I have a fundamental issue, but we can take that offline. I'll just pretend I wasn't here today, and then we'll get it figured out, and then I'll just rewatch from there to get everything going.
Okay, sounds good. James, you said that you lost the button to import. Were we supposed to do it twice? So that probably means you didn't truncate the table. So you'll want to run a statement that allows you to drop all those columns, or not columns, sorry, all the rows that were in that table. Did you run the alter statement to change the data types for those two columns?
I think I may have skipped. That's why I was only seeing export. I'm like,
So yeah, that is also a possibility. We want to do both of those steps. So since we imported our data after we declared the schema and that schema was incorrect, the next steps that you can do, which you can do it in any order, are you'll want to remove all the data from that table because we imported it incorrectly. And then we also want to alter the table. So we want to change that schema, the data types of those two columns that were problematic, to something that's a little bit larger. So we'll write an alter statement to change those data types. And it's as simple as alter table and then your database dot table, modify the column name that you want to modify, and then the data type that you want to change it to. And we want to change ours to decimal 10, 2. So I will actually copy some code over here that you can use to modify both of these with.
okay.
Just give me one moment. And I didn't even realize this. Ted was actually sharing the exact code that we're looking at. So your alter statement should look fairly similar to what he's got here. And you'll want to run these preferably in order. We want to alter the table columns first, change those data types, and then truncate the table, which removes all of the rows out of the table, but keeps the column declarations that we've already made. And then we'll reselect everything out of the table that, there should not be any rows in there, but we will at least get the table outline to pull up. And then with that select statement, you should be able to find that table import wizard again. And then Anna, you said you were also having difficulties. We can work through yours now if you'd like. We also can't hear you if you're trying to say something. Okay, technical difficulties. We'll chalk that up. Charity, were you able to get the scripts to run?
No, and I was just gonna ask, can we work through mine? Because I don't know what the error message is that I'm getting.
Okay. Does it tell you what the error message is?
Yeah, so let me get up. It says error unhandled exceptions, ASCII, code C can't decode, byte 010 XE2 in position 1896.
Okay. Are you using the Mac version of the CSV?
It's- Oh, yeah.
You were?
No.
No, you weren't. Okay.
That's why.
Okay. Let's try it with the Mac version. Fingers crossed that works. I at least kind of prepared for that one, so I'm hopeful that it does work.
Are you able to hear me now?
Yes, we can hear you.
Oh, I had to go say something. So on mine, it just doesn't let me select an existing table. Like nothing shows up.
Okay. Could you share your screen?
Yeah.
Okay. So it's given you the exact same error it was giving me just a little bit ago.
Yes.
So for you, here's what we're going to do. We're going to create a new table and we're going to call it biking_2. So on that right, well, you can go back. It was actually just the other option that you didn't have selected. So if we have this selected correctly, click next, create the new table, call it, learn underscore, do biking_2, and then click next. And then everything looks good here. So go ahead and click next again and click next. We'll run through the import.
While we're waiting, one thing I found interesting was when we did this import, when it gives you the preview, it looks like it is proper, but then you do the select and, you know, once you have imported it and you do the select all from that, it didn't show proper. So it was kind of misleading.
Yeah, I kind of thought the same thing too. Okay, so Anna, for your example, so we just imported all of that data into a different table. So on your schemas tab on the left side, could you expand the tables breakout? And then can you hit the refresh button? So we have the biking 2 now. And you did run that alter table statement for biking, correct?
I don't think I ran anything. I just wrote it in there.
Okay.
Because I didn't have anything. I didn't what is it? I didn't import anything before when we were doing all that.
Okay. We'll still want to run the alter table statement because we do need to change our schema. So run that. No column, average miles per hour. And that table did get created. I wonder if we have some other issues going on because I think James ran into the same problem here. Let me log into the admin account quick. And it said average MPH is unknown. I see that column there. Modify distance, decimal, modify average MPH. Oh, it's because you named the column average instead of AVG. So instead of AVG in that down just a little bit, or you can copy that entire thing into the alter table statement. And try running it again. All right, and now we should be good. So run the truncate statement one more time. Now the next thing we're going to do is we're going to actually import the data from that biking _2 table into the table that we've already declared. So add a couple extra lines, and now we're going to do insert into.
Oh my goodness.
And then the table that we want to import into. So from your select statement on line 10, take the database and table name from line 11. Because we want to insert into that table.
I don't like my keyboard.
And then after that, just on another line. So go to the next line, select star from the table. Yeah, select star from the table that we had just created, which is that biking 2. So learn your name database dot biking _2.
Okay.
And then terminate that statement with a semicolon and run that.
The whole thing, including insert?
Yep, the whole thing. And now all that data that we imported is now in the right table. So it's in that biking table. So now we can drop that biking _2 table that we had before. And you can do drop table and then your database dot biking _2.
This one.
Technically, it's the next one, that biking _2, but you can just put _2 there. And then terminate with semicolon, run. And now you are good to roll.
Thank you.
Yep. Okay, so we've spent a little bit more time than I was anticipating on this particular module. We've been going for about an hour. So how about we take a break? And then James, we're going to try and troubleshoot your issue as well. Charity, were you able to get everything to run correctly?
So I was able to get it imported, but
Okay.
now I can't find it under the tables.
Okay. We'll also investigate that too. So we'll just stay here. Everyone else can feel free to take a 10-minute break, and we'll resume class at 8. Let's call it 8:05. We'll start getting back into lecture, and we'll talk about some of the other ways that we can translate data. I don't anticipate we'll run into a lot of additional problems with the next couple of methods or the next method. So let's take a break, and James and Charity, let's make sure that we can get your tables in order.
All right.
I always forget that I have to add an extra hour to the time I'm looking at on the clock. All right. So Charity, you said that you had the data come in, but you're not finding the table. Is that right? Or you can't find where it went?
Yes.
Okay. Looks like you have a biking Mac table in there. So I'm going to open up a new query window.
Maybe I need to refresh it. Hold on. Yep, I just need to refresh it.
Yeah, it looks like the data's in there. You were able to get it to load successfully. It's stored under biking_Mac.
Yeah, I refreshed the and now I can see it.
Awesome. And just a tip, if you know that the table's there, you can still query for the table if it doesn't show up in your navigator. But every time that you add something or you change a table, you will have to click that schema refresh button in the top right for any of those new tables or updated columns to reflect that in your browser. So awesome. Well, glad we could get that sorted. We still have data, so feel free to take a little bit of a break.
So, question.
Okay, question 2. That's great.
When I was trying to do the Netflix one, it wasn't importing. That's where I was having that error message. But when I did the biking, it went through just fine. Is it because there's probably more data on Netflix than it was on biking?
So that is actually a possibility, which I was going to discuss when we started talking about the next way to import data, which is the exact reason why I wanted to discuss this method, because I probably ran into the same error you did. A little bit of the technical behind it. What happens from a database administrator perspective is everyone's account on the database or their user account is generally limited based on or to the number of queries, the number of questions, as MySQL refers to it as, that you can ask the database engine in a single hour. And so when you run through these large data sets, some of the rows may be more than one question allotment, if you will. So when I tried to import this biking table limited at I think it was 1,000 or 10,000 questions an hour, I actually maxed it out, even though it was only 135 rows. And so that was why I knew we were going to have to talk about the alternative method, which is a little bit different, but you're allowed to write significantly more data in a much faster format than what you saw with the import wizard, because it shouldn't take longer than a second to write to a cloud database for 130 records. That's not a lot. But you'll see with the Netflix database or the Netflix data set, for example, there's, I think, 8,000, 9,000 rows in that table,
Yeah,
which is a lot. So we might surpass the amount of questions, but we can actually code our insert statement to accept all the values at once, and it won't take nearly as many questions. We'll have a very long block of code that we have to copy from the web browser into MySQL Workbench. But I'm wondering if that's the same issue that you ran into with the Netflix data set.
Yeah, I think so too, because then when I was actually going through it, I was like, okay, well, the Netflix one looks way more than the biking, so that's probably why.
Yeah, I think that's probably why. But I'll discuss that a little bit more in depth when we go through the next method. So sounds like break time.
All right, sounds good. Thank you.
All right. James, man of the hour, let's try and get your stuff squared away. I think I might know what's going on. We may just have to retry this. Would you be able to share your screen and I'll walk you through?
Yeah. Can you see that?
Yep, I can. All right. So you just ran that select statement and there were no rows returned, right?
Right.
Okay. Could you write another statement right below that select? Type describe learn underscore jjones dot biking. And what this command does is it'll return your entire schema for the table. So it'll tell you what columns you have. It'll show you what they're stored as, whether they can be null, the keys like we talked about. So if there's a primary key or a foreign key constraint, it'll tell you if you have anything. And so I'm looking at just the field names, and we have, it looks like it took, when you imported the file, the exact column names that are stored on the CSV itself. So we may have to change the statement just a little bit. So when you say you didn't have anything in your biking database, right?
Right.
Okay. So let's try this again. Can you scroll all the way to the top for me? So we have learn, and you were able to run this statement, right?
Yeah, the first time.
Okay. Let's start over from scratch. Let's drop this table. So right above the create table. So just hit enter a couple times there. Write drop table, and then that learn underscore jjones.biking. And we'll start from scratch. We'll rewrite the query. We'll rewrite the schema or the create table schema, and then we'll import again. So go ahead and drop the table. And then on the distance and the average miles per hour here, change the decimal from on distance from 3.2 to 10.2, so we don't have to run the alter statement again.
Cool.
And then on average miles per hour, change that from 2.2 to 10.2, and then run that create table statement.
Should it be the full word average and not just the abbreviation or the full?
You can name it whatever you want.
Okay.
And then go ahead and run that. And the table should be there. So select all from the table. There we go. Now we have the import wizard. So we'll want to import. And run the biking.csv.
Yeah.
Click next. Try the use existing table. And if that doesn't work, yeah, so click the drop down. And if it doesn't put anything in there, yeah, so create a new table, and we'll do something similar to how we did, or what we did with Anna. So create a table called biking_2, and then click next. And this is just going to create the table with the data that you see here. Yep, and all of this looks fine. It's going to import distance, and average miles per hour is double, which I had talked about was, it's fine. It's the same thing as a decimal, but go ahead and click next because this all looks good. And then it's going to run the import. And we'll wait a little bit. All right, we should be good here. So go ahead and click next and finish. And now what we're going to do is refresh your schema explorer on the left side just to make sure that the tables are there. So we got biking and biking 2. The data lives in biking 2, and we want to get it into the biking table. So we're going to insert the data, or we're going to insert into biking all the data from biking underscore 2. So what we'll want to do here is write insert into, because we want to insert data into the table that we wanted it to go into first, but we just ran into some problems, which in this case is going to be learn underscore jjones dot biking. And on the next line, we don't have to terminate it yet. We'll just write the query that we want to insert into this table. So since the schemas are the same, we'll just write select star from learn underscore jjones dot biking 2 or biking underscore 2. And then we'll terminate it now because that's the end of our statement, and we'll run it. And now we can select all from the biking table again. And boom, we have our data. We are in business. So the last thing that we want to do is just a little cleanup job because that biking 2 table, it has all the data that is in biking. So we're actually just going to drop biking underscore 2. So the code to do that is just drop table, learn underscore jjones dot biking underscore 2. And now we'll refresh the schema explorer and we should have 3 tables. All right, perfect. We are done.
Mhm.
All right, we have about a minute left of break time. So I am going to go take a quick break. We're actually going to resume here in 5 more minutes. So we'll meet back here at about 8:10, and then we'll go through a little bit of lecture. Hopefully we get to joins tonight, but I anticipate we'll be here the full hour till about 9 o'clock. So I will be back very shortly.
Okay.
All right, everyone. So it's 7:10 or 8:10 Central, 7:10 Mountain Time. My apologies. So let's go ahead and get started again. Share my screen here. And let's make this last 50 minutes count, shall we? So we just went over how to load data using the import tool that's built into MySQL Workbench. But what happens if you have an application that you want to use to collect data and then insert into a table that you've already created on the back end? That's actually where using the inline SQL comes in. So you can either use a SQL file, or when you write an API or an endpoint or anything that communicates with the database from the application, you'll generally have a SQL statement that declares what data you want to insert. So you're going to just use a straight up insert into statement where you insert into the table you want and then define the columns that you want to insert each of the pieces of data into. And then after you've declared all the columns on the table, you'll write values, and then you'll have another parenthesis value for your entire row of data that you'll put in. So you'll see we have insert into table, and then column 1, column 2, you may have 3, 4, 5, 99, 175. Hopefully your tables don't get that wide, but just to show you that theoretically you could have very wide tables that you import. And then for your values, the way that your values parenthesis will correspond with your table name column declarations is it's in order. So the first value that you put into your values statement is going to correspond to whatever you put in that first block for your column declaration in the table name insert. So if you wanted to insert into your biking table, for example, your insert statement might look a little something like insert into, and in this case, learn_s.mcquiston.biking sessions. And then in this block of parenthesis, you'll have ride number, comma, date, comma, distance, comma, time minutes, comma, average miles per hour, comma. And in the case that you have an auto increment, you can actually skip that column entirely because MySQL Server is going to do all the work for you. It knows what the maximum value is that you're importing, so you don't have to declare that if you don't want. So let's say ride number was our primary key, and we put a constraint on the column that says we want to auto increment it. You could actually have a insert statement that looks like insert into biking sessions, and then your values are starting with date, distance, time minutes, average miles per hour. And then your values will just correspond to the columns that you put in here. So if your first column was date, then the first item you want in your values statement should be your date. And then your second column would be your distance. Your third column would be time minutes. And each of these values, I would recommend you wrap these in single quotes because it'll allow you to just easily differentiate where the data is and find it instead of trying to get a column. There's also the potential that if you are inserting values that contain columns, that you want to include the column in, or you want to include the comma in the column value for that row. So if you do everything in single quotes by default, it'll allow you to add a comma value in your insert into statement. These are just programming syntax issues, small things that you may run into. But that's how you would actually write the insert into statement if you were programming an application to transmit data to a database, or even if you wanted to just insert a row into a database, you would do something similar. And then I know that this isn't on here, but we talked about being able to create, read, update, and delete just about anything on a table. We could create a table, we can read from a table, we can update a table, we can drop a table, we can create a column, we can update a column, we can read from a column, we could delete a column. I think we've run through every example there tonight. But the same goes for rows. We can create rows using the insert into statement. We can obviously read rows using a select statement. We can update rows by running want to say it's a, let's see, update rows in MySQL. You can update a row by saying update your table, set your column equal to whatever value, and then you would want to add a where clause if you want to update a specific column. So to demonstrate that, if I were to, so I don't have anything in here, I'm actually going to volunteer. I'm going to volunteer Ted's table here. So I'll open up a new query tab. Sure, I got that table name right, Viking. All right, so I run it. So let's say I wanted to update my first ride, and maybe we had like a data integrity or a data quality problem, and the right value didn't get written. Or maybe you just want to override the value that you were there or that you had in there. Maybe I just want to inflate my numbers a little bit and be able to prove that I'm progressing on the speed that I'm biking. All you would have to do is say, I want to update this particular table, which in this case would be the learn_.biking. And then you would set the column name that you want to update. So in this case, I would want to update let's update the date. Let's say that I recorded the date wrong. You could set date equal to, and maybe I want to change this first row to 2021 05/17 because I recorded it a day late or something. If you want to update just a single row, you have to make sure that you define what that row is you want to update. So in this case, if I want to update ride number 1, then I would say where the ride number is equal to 1. Terminate that statement, and then I could run it, and you would see that the date is now changed to what we're trying to overwrite it with. And so we've talked about creating rows where you use the insert into statement. We can read with a select statement, and we can update using update. But what if we want to delete something out of a table? Well, we also have that ability. So if we wanted to delete row in MySQL, we would write, instead of update, delete from learn _ whatever our name is, biking. And we would just drop where the ride number is equal to 1. And what this statement would do is it would drop this first row from our table entirely. It would no longer exist. The only way that we could get it back into the table is if we either run an insert statement with these values, or we truncate the table and reload the data that we had when we loaded this originally. So this would be an example of refreshing the data with the most current values from our source table. So, but anyway, back to the PowerPoint. So we talked about loading data using the import tool. We talked about loading data using a SQL file. But what happens if maybe our file's too big and we can't use the import wizard, or we don't want to write something that inserts maybe thousands of rows? Well, there are workarounds that you can use. If you were in like an enterprise architecture, in this case, you might want to use the Amazon data, or like since we're on AWS, we might want to use a tool specifically for AWS data migration to copy a large file into a database, simply because it's a cloud hosted database. But an alternative around this is we can actually use a tool found on the web. All you have to do is search CSV to SQL importer, and hundreds of results will pop up. The one that I would highly recommend you use is actually this tableconvert.com source, just because it has a friendly UI. And when you go through here, the only thing that you need to know is the table that you want to import, where you want to import it, and what the column names are. And the tool will do the rest for you. So I'm actually going to pull this example up, and we're going to walk through this together. So I have table convert pulled up, and let's say I want to load the Netflix titles example. All I'm going to do is click load file, or whatever site you end up using. You'll point to the file that you want to use. In this case, we'll use Netflix titles, and it's going to load this into the online editor. You'll see how quickly it pulled all of this in. And now it's parsing it out and it's saying, okay, well, I know what's in column A, B, C, D, E, F, G, so on and so forth. But I want to just generate this entire table. And I think in here, I wonder if it's actually getting these as table headers. I think there's an option down here. But we can update all these different variables. So it's going to actually spit out the create table statement for us to run and create the table in our database. And then it's going to, oh, it's got a lot of blank columns in here. So we may have to also update this. Let's actually use a different example. So we'll just Google CSV to SQL converter here. And this convert CSV I've used before. So when we use this, we can choose the file again. And I'm going to paste this for everyone so that we can follow along. So I'll paste this in our Slack channel. And you can pull this up so that we can do this all together. But once you're here, I'm going to choose the file. And I'm going to click on the Netflix titles example. And then I think it takes just a little bit here since it is so it's going to tell us that we do have headers, which are what you use to like name the columns. It's saying that it's detecting 12 different columns in this table. The separator, which is what the file uses to indicate like a termination of either a column or going to the next row. And in this case, the separator is just a comma to differentiate a column value for a row versus another column value for a row, so on and so forth. And we've got 8,800 records. So if you think about the amount of time that it took to import about 134 records for that biking table using the import wizard, if we were to use the import wizard again, barring all of the technical things that I had described over the break, in case you weren't here, it would take a long time. And so when we run a SQL file, it's going to run a lot faster than the import wizard. And we can actually customize this to go pretty quickly. So to go through all of this, since we have our output options, the input options, if your first row of your table is just column names, you would want to make sure that you have this option selected so that you don't import the column names as like a value in your rows. We don't want to limit the number of lines and we don't want to skip anything. And generally you can auto detect what the field separator is. In a CSV, it's generally either going to be a comma or it could potentially be a pipe character, which is underneath most of your backspaces on your keyboard. We don't need to replace accents. We want to we don't need to do that. Don't need to do that. And we won't have this. So now we need to choose our output options. So down here, we'd be able to rename any fields if we wanted to, change the data types. And like I had mentioned before, what these tools generally will automatically do is look at how long your max value in a particular column is, and then set that as the max size so that when the import runs, your data type declaration won't cause any syntax errors on the import. It'll allow all the values that you have in the spreadsheet. So what do each of these columns do?
I think I skipped a step. Pardon me. After you selected the file, what did you click to make the field name show up?
Oh, you have to wait a little bit. It's just depending on the browser. So it should take like maybe 30 seconds, 45 seconds.
Okay, yeah, mine is still just showing field 1, 2, and so on and so forth.
Okay, so it takes just a little bit for it to load. I can wait. Is anyone else having kind of the same problem where it takes a little bit to load?
Yeah, mine just it said unresponsive. So I tried it a couple times and it still just went on. Just broke the page or whatnot. So
okay, were you able to get it to load though?
No.
No. Okay. Okay. Well, I'll walk through this example and I'll try and diagnose this problem later, because I was actually going to have you run through the same example on or for the homework, but we may have to change course. So we'll continue through the example. I'll talk about each of the different fields that you might want to bring in and some considerations to make. And then we'll start talking about joins since we're getting close to the end of class. So if you're able to get to the screen where you can see how the program actually parsed all of these columns out, key is going to stand for primary key. So we had talked about what a primary key is. It defines what each row represents or how the table could be measured. Include just means you want to include that column in your data import. Required, this is another name for not null. So if you click required, then it requires the field to have a value. It can't just be blank or unknown. Trim, I would recommend using trim on every column. So what a trim function does is if there's any spaces at the beginning or the end of your column value for the row, it'll automatically get rid of that and look at the first non-space character or non-blank character and the last non-blank character and trim the length of the column down to just that. So it'll remove any extra spaces that might be included in the value as a result of just a data import or a data transfer. And then we also have upper and lower. So what these are also two functions that are built into SQL. An upper function is going to take the entirety of your your varchar or your string character, and instead of being in lowercase or in uppercase and lowercase, it'll be all uppercase. And then for lower, it's the exact opposite. Instead of being all uppercase, it's all lowercase. So there's a lot of times in like data engineering where you may not want to use uppercase letters, or you may want to have everything be lowercase letters. Or if you do like an automated schema generator, you generally want to either use all upper or all lowercase. And if you have spaces in a column name, you could actually run what's called a replace function and then replace the spaces in those column headers with whatever you want. So you could remove the spaces entirely and have what's called camel case, which means you have a capital letter for your first word in the variable name and then a capital letter for the second name in your variable name. So like instead of, if this was show space ID with a capital S and a capital I for show ID, and you wanted to show it all in lowercase and you wanted it to be show underscore ID, you could run a trim function to reduce the amount of characters in that column. You could then run a lower function to convert all of the text to lowercase function. And then you could replace any of the spaces with underscores, or you could replace them with blanks. So there's a lot of different options that some of these tools will give you when you import the values. But when you go through here, you're going to want to also change a few other options. So we want to create the table view, and we also want to drop it if it exists. So what this does is if you were to run every command, the first thing it's going to do is it's going to say, if I have a table in my database at all with the same name, just drop it. Because we're going to reload it and we're going to put brand new data in it. The other option is instead of that, you could create the table and then truncate it, or you could just truncate the table if you think there's data in there. And then let's see, for insert, we don't need to use replace. We want to use just one insert statement. Because if we don't, then we're going to have multiple lines for insert. So you see here how we have the script showing create table and then all the variable names. And then each line is actually showing insert into my table with the entire schema printed out. Sorry about that. So we have insert into my table with all the schema. And then if we scroll over, well, if I could scroll over on this little box, we have all the values for each of these lines. Well, what we can do is instead of having a insert into, we can have this all be a part of just one line. So we have create table, whatever your table name is, all your columns and all your column declarations, and then insert into your table with the column name declaration, and then values. And then each of these value blocks here, at the end of it, there'll just be a column instead, or a comma instead, sorry. And so it'll be a block of value for a row, comma, another block of values for another row, comma, another block of values for another row, so on and so forth. And so this will take out a lot of the text that gets generated in the script when the program creates it. And then we don't need to merge. That's a little bit more complex than the scope of this class. And I don't think we need to update anything else. So I'm going to click the CSV to SQL insert, and I'll wait for this to rerun. And now I have the insert statement spit out exactly like I want it. So I'll take this entire block of text and go over to my SQL editor or my SQL workbench, and I am going to paste the entire thing in. And when I paste it in, you see we have 8,800 lines, and we're going to import all of this data. So I'll scroll up and we'll run these one at a time. And I didn't change the name of the table. So what I'm going to call this is, and I would recommend doing this in the web editor beforehand, which can be updated here. So for this example, let's just call it Netflix titles. And I'll regenerate this. You'll see that the drop table, if exists, and the create table change. Over to my SQL editor, paste this in. I'll scroll all the way back up to the top. We'll drop the table if it exists. Oh, no database selected, that's why. So in this particular example, you'd want to declare that we want to use our database. So for me, it's learn_s_McQuiston. Run it, drop the table if it exists. I get a warning. There is no table with that name. Then I want to create the table. So I'll run that. I get a success. And the last thing that I want to do is run this insert. So it's pretty long. And since I've already run the rest of the script, I'm actually just going to delete it. And then I'm going to I'm going to use Control-A to select everything in the script. So everything should get highlighted. And this may take a little bit because it is quite a bit of data, but this is the better option compared to running the import wizard just because of the size and the amount of data that it's looping through. And then when we run it, we'll notice a big difference in the amount of time that it took to import all of this data. So I'll run it, and it's running, and it should complete. Yep, 3.4 seconds. We imported 8,800 rows. So if you remember how long it took to do the import wizard, it took roughly 30 to 45 seconds to import about 130 records. Just using this insert statement with a SQL file ran through nearly 800 times the amount of data in a fraction of the time. So you can see why there are different workarounds and there's different methods of getting all the data imported. But this is one of the ones that we can use for our environment. And technically, you'd be able to do the same thing for like your organizations or enterprises. You may not have the ability to create new tables, but you may have your own environment where you could insert any of the data that you wanted. You could copy data over from another table. You could run through this same exercise where you have a CSV that you want to put in a database, and all you have to do is generate all of like everything that's there. So that is just an example of like how you could use different tools to import data into MySQL. So if we had I know we had some issues with like slowness. Was anyone actually able to get it to run successfully? Or was anyone able to get the program to spit out the SQL code for this? I'll take that as a no. Okay. Well, that is good to know. Let's go back to the PowerPoint and let's talk about some joins. So what can you do with all these tables? We've talked about getting more tables into a database. We've talked about manipulating columns and tables and their values. But once we add more and more tables into our database, we can start to actually measure our data set based on values from another table. So once we get a table in there, we can actually start to understand it further, run statistical analysis on it, like value frequency, how many values are in the table, or how many values are there that match a certain criteria, thinking about like running a case statement or even just grouping by a value in the table. Maybe for our biking database, we had weeks where we had multiple bike rides, but weeks where we had none. That would be an example of where you could count the number of rows or count star from your base table, in this case, biking. And then after you join the calendar table, you can roll it up to a week and say how many bike rides occurred or how many records on that base table occurred in the days that are selected or grouped by. You could also do aggregates by group. You could sum or average. So if you wanted to know how many miles total I biked in a particular week or a particular quarter, you would be able to do that with another table join. Or you could run an average to see what the average was over a moving period of time. And then another thing is you want to find outliers. That's why the min and max statements are valuable. If there's data that's lower than you expect or higher than you expect or significantly lower than what the median or average value is in your data set, those would be candidates for removal if your use case permits them. So after you do some of this basic data, or after you do some basic data cleaning to ensure consistency in your column data types, kind of looking at the dates in particular, and then string values if you have any, then your tables can get joined together, which, like I was talking about, that's where you start to get a lot more powerful with data analysis. We can use multiple tables, join them together, and do what's called multidimensional modeling, which is where you may have like a fact, for instance, or a measurable, call it bike riding. And maybe we have things like weather data that we could join based on the day, right? We might have date roll-ups that we want to do where each date corresponds to a given quarter or a given month or a given week. And if we wanted to know how fast we were able to go or like what our average speed was by week, depending on the weather or even by day, these are things that we would be able to do with those additional table joins, some new logic, and just a little bit of creativity. But these are the things that businesses really want to do right now because you can look at factors that are totally out of control of what your underlying measurable is. So I'm thinking like sales. With multidimensional modeling, if you have a sale, you might know what day a sale occurred on, right? That would be an example of a join you could do from a table to another table, like a calendar table. And it would be joined based on that particular day, right? So you could then count all of the sales that you had in a particular week. But now let's say you want to count the number of sales that occurred in a week for only a specific product. If that sale record has a foreign key relationship to another table, like a products table, you would be able to join it on a similar column name and then pull that data in and say, well, I want to pull everything that joined on these tables and where the date is what we were expecting it, and the product is what we defined it as. At the end of the day, you're probably wondering the same thing. Yes, it's mostly all spreadsheets. I remember when I came to this conclusion too. I always thought data analysis and data prep, data engineering, all of this was extremely complex, which it is. But at the end of the day, everything boils down to rows, columns, in a table. And those tables can be used in the form of a spreadsheet or they can be in a database. They are similar, and sometimes spreadsheets feed databases, and databases can generate spreadsheets that then can get manipulated even more by human interaction and then reloaded back into the database. So you can see how it's a bit of an endless cycle potentially, but this should show you that data comes from a multitude of places. We can import tons of different sources. And at the end of the day, wait, it's all spreadsheets? Always has been. Why might you want to join data? Some tables can get pretty large, not just in terms of rows, but in terms of the ways we may try to measure something. One table may not provide us everything we want to know about a particular data point. And when we talk about the 5 V's of data, this is what I was mentioning about the considerations we have to make for how we model where we store data. Transactions like a sale log, or even Internet of Things transactions or records. So I'm thinking of Ted and James, your examples of what you guys do. It's healthcare data. You may collect hundreds of thousands, hundreds of millions, maybe even billions of records at any given time. And when you want to run analysis on that, your backend architecture will ultimately be modeled out into potentially 2 different models, an OLTP database and an OLAP database. The OLTP database is what you'll use to feed applications, and the OLAP database is what you'll use to run analysis on this. And OLTP databases, sometimes you only need to refer to like one record or a set of records, or you could add views that are specific to a device or a user or an application that are easily accessible, to the point where the additional data modeling you need for analytics may not be necessary. But why are there different ways of storing this data and organizing this data? Well, data comes in a lot of different shapes and sizes: volume, variety, velocity, value, veracity. And if you subscribe to the school of 6 V's instead of 5 V's, we also have variability. But what does that mean? Well, volume refers to how much data we're processing in terms of records or rows and columns, because ultimately those cells, each of those cells takes up a size of, or a chunk of data. And the larger your data set becomes, the harder it becomes to then process or return results. And then variety, what like range of data are we working with? How much data is there? How diverse is it? You can start to break these out by different cohorts or different groups of data to determine how diverse it is and what kinds of statistics you might be working with. Velocity refers to how fast you're entering in new rows or updating rows. I think about like Facebook, for instance, right? As a social media company, there's tons of data coming in nonstop. There's a couple of billion users, I believe, and each of those users will generate information like when they signed in, what ads they saw, what elements of their newsfeed they interacted with, what pages they visited, tons of different things. And so when they deal with all of their velocity of data, they have what's called batch streaming. So batch streaming allows you to insert records in real time and then update OLTP and OLAP databases. So the technology continues to advance, and the abilities that we have to manage and manipulate this data is immense. And then with technology advancing, we have improvements in our ability to process data. So some of these things that I mentioned today may not even be applicable in 10 years just due to the way that technology progresses. So it does pay to stay up to date on these kinds of things. And then value and veracity, finally. Value refers to what this data can actually do for us. So how much could we theoretically monetize out of what we're collecting? Is the data that we're collecting actually worth it to us to store? Even though data storage is so cheap, if you're storing a lot of data and you're adding in columns that are unnecessary to what you're either measuring or building an application on, it's probably maybe not worth it. So you may consider to not store a particular column or not even bring it into like your analytical database. And then we have veracity. Finally, I know this should be the most important one, but veracity tells us if we can even trust the data. Is it logging correctly from source? Did the table import run correctly? And if it didn't, where did it fail? Why did it fail? What are the values we were expecting and why didn't we get them? ultimately, all this analysis that we do, all the querying and all of the modeling that we do means nothing if we can't trust the source of the data. So veracity is important when we talk about joining data together, making sure that we can run analysis on it. Any of the statistics we pull are dependent on the accuracy of that data at the time it's written. And so finally, let's talk about how joins work. You may have seen these Venn diagrams before. They are very common. They talk about, it gives a good visual of like how joins work. You can think of each of these circles as a database table, and anything in the middle indicates a successful join. So that means that if you're querying a table and you join like the calendar table, for instance, anything that has a value corresponding to that date that's on your first table that also is on the calendar table will show up in that middle part of the Venn diagram. That means that there's a match. And then we can also include or exclude certain parts of the data set. And there's certain conditions, or there's certain cases where we might want to use each of these joins. But even though there's 4 primary types of joins, there's a lot of derivatives of those joins. But I'm only going to teach you in depth on these 4. And the 2 most common joins that you'll use in basic data analysis, data warehousing, and data science are going to be inner joins and left joins. And optionally, you can use the outer clause on your left outer join. That just indicates that you're going to return any results that don't have a match on your base table. So that means that the join to the other table failed, but you still want to return those records. So what are some cases that you might want to use each of these joins? Well, an inner join is going to show only columns and values from the base table where the columns and values on that joined table match. If they don't match, then you won't return values from either side of that table. So any values on like a sales table, for instance, you might want to return every transaction you've ever made, but you also want to know what kind of products you sold. If you do an inner join there, you're only going to return sales transactions that had a joined product detail record from another table. And I'll go into more of these in depth on the next slide. But for the left join, that left join is only going to show columns and values from your base table, and it's going to show all of them. So you don't have to worry about matches. And a case where you might want to use this is where you have like, let's say you have the same example of like a sales table, but you don't have a good join model to like your product table. So you have missing products. But you may have values on your base table, like how much the product was sold for, how much you bought it for, when you sold it, and you may still want to return statistics for that entire sale record. That'd be an example of where you could use a left outer join to identify everything that has a match, and then maybe even aggregate it up. Say I wanted to return total revenue for all of my transactions, whether or not I can join my product table, and I still want to group it by like the product name. But I also want to show that if there wasn't a valid product for a sale, that should go in like a null bucket so that I can start to work through those values that don't match and maybe try to clean the data and figure out what those products should be. But those are the 2 most common joins that you'll use. You'll frequently use inner joins to join tables where there is a match, and you'll use a left outer join frequently in applications like data warehousing, where you may not have a perfect match, but that still doesn't defeat the purpose of your underlying like fact measurable. And some of these terms I'm using, like fact and dimension and join, will make a little bit more sense when we get to the next class, when we start talking about OLTP databases, OLAP databases, and get more into business intelligence and data modeling. And that's more of the higher level overview of like the entire data stack and how we derive value out of all these tables, all these columns, all these rows that we create. The other 2 join types that I want to discuss with you that aren't used as frequently, but each have their own purpose, are right join and full outer join. So when you do a right join, you're only going to show columns and values from the base table that have a match on your join table. And then you'll also return a row for each value on your joined table that didn't have a match on your primary table. So think of like the sales table and the product table, for instance. When we join those together, you may only want to see values that, or you may want to only see transactions that had a corresponding product record, and then exclude any transactions that didn't. And then you also want to see which products had no transactions associated with them so that you can investigate maybe if there's a sale or not, or if it's even valid. And then the full outer join is going to return all columns and rows from both of the tables. And if there's not a join on your like sale table, it'll show all nulls for the product information. And if you don't have any sales for a particular product record, it's going to show null for all of your sales columns. And then it'll show you what the product details are that had no match on your other table. And then on the next slide, I talk about each of these examples. So when you do your inner join, that bottom left Venn diagram there, you can think about your data on maybe like sales deals, which is table A. And you only want to see the sales that have a matching invoice record, which could be column B. So we're going to exclude any sales that don't have an invoice, and we're going to exclude any invoices that don't have a corresponding sale record. Left outer joins, a case where you might want to use this is if you want to sum revenue from all of your sales. So this would be like sum revenue on table A, your sales table. That's the A outer part. And then regardless, you want to return all of those data points regardless of if there's a matching product record. So that would be your B table. You return any matches, but you exclude any of those dimensional records that don't have a sale on your table A. Your right join, an example where you might want to use this is if you wanted to list every single sale that you had that had a matching product record, which is A and B, in addition to having a row with just blank sale records for every product that's never been sold. That's your B outer on that Venn diagram. And then your full outer join, this is where you might want a list of all of your sales and join them to your product details table, regardless of if there's a match or not. In addition to a row for every one of your products that doesn't have a matched sales transaction. So you'll have rows, you'll probably have sales rows with no corresponding product dimension, and you'll have product detail records that have no sales associated with them at all. This allows you to pretty much analyze every perspective of this data that you can, and in every use case possible. So you can see how joins can start to get pretty interesting when you want to learn about trends and data and how it relates to different data points that are stored on different tables. But the possibilities are endless. And so I'll skip this part because I kind of discussed this just a little bit ago. But I also have this blog post that you can read about how table joins work. It goes in depth on each of the different join types, some cases where you might want to use it, and it shows you using 2 sample tables what the results are if you were to use a particular join. You can think of these tables that we're using like bricks, and all of these tables are going to be built into something big, right? The joins are the concrete that we're going to use to help lay this foundation, and we'll eventually build a house. Maybe a data warehouse where we store all of our data that we've ever collected, and we'll start to join it and we'll start to model it out so that we can draw some sort of analytical value out of it. Are there any questions about table joins? I know we kind of breezed through this, but we are going to touch on it next class and go more in depth and do some examples as well.
I got nothing.
All right. So
no questions, but I was able to get that table to work.
All right. So it probably just took a little bit then.
It took a while.
Yeah. How long do you think it took if you had to like put an estimate on it?
It took like 4 minutes, and then it stopped saying fields and it showed the actual names, and then I just remembered everything that you selected and copied and pasted it. into my workbench.
Awesome. So it did work. That's great to
I
hear.
will say some directors in CAS show null. Is that okay?
Sorry, could you say that again?
There's like null under directors and cast members. I remember having something checked about null, but I don't remember if that was to allow null or to not allow it. I do have some null values though.
There might be null values. I haven't fully investigated the data set.
Okay, cool.
So that's totally possible.
Okay, cool.
Any other questions? All right. Well, let's round class out. So let's review. What did we talk about tonight? A lot, but more specifically, we learned about the types of data sources that we can find online and easily analyze. We talked about the multiple ways that we could potentially even insert this data into a table. And we talked about how we create tables, update columns, drop tables, truncate tables, tons of different actions. And these are all going to be related to how we get data into a database, manage it, and even change it long term. And we also learned very briefly, about joining data in a number of different ways. And each of these joins behaves in its own unique way. But at least we did go over some examples of when each join may be justifiable to use over another type of join. But that's class. So for homework, since we won't have class for a week from today, I'm going to send out our homework assignment with instructions tomorrow night. Anyone that was able to get the Netflix titles to load, great. Otherwise, we'll use the toy sales data set because that's a little bit smaller, so you shouldn't run into the same performance issues that we did with that Netflix titles data set. So we'll likely use that for the example for the homework. And then our next class, as a reminder, is going to be next Wednesday. We'll talk more about joining data, doing database modeling, and then the differences between OLAP and OLTP. But that's all we've got for now. So thank you for coming tonight. And I hope all of you have a fantastic weekend, and we will reconvene in 7 days.
Got a question. The homework, when is it due?
The homework will be due before the next class. So we'll have, assuming I get it out on time tomorrow, you'll have about 6 days or so to do it. It shouldn't take as long as the last assignment. I'm planning on making it more of an instructional walkthrough and then having you just do some queries to understand what's in that data set. So that's the plan for homework as of now. Any other questions? All right. Well, I think we'll end class there. We made it in under 3 hours. So again, thanks for attending, and we'll see you all in 6 days, 7 days. Have a great weekend.
Hey, Sam, can you stay on for just a minute?
Yeah, for sure.